Okay, so we look on our latches first. Just now we know latch got 3, SR, gate SR, and gate D. So for latch is a type of temporary storage device. So this kind of question normally will be asked in your part A, your multiple choice question, whether what is latch? Which is the correct statement about latch? So you need to know latch is a temporary storage device. Sometimes it's just change. Latch is not a temporary storage device. Is it correct or not? So you need to know the true and false statement also. It has 2 stable state, which is bistable, and latch is level sensitive, which is level trigger. Later you're going to see the differentiation between latch and flip-flop, which is it is depend on the voltage level applied, not on the signal transition. There is 3 types. This one is repetitions, SR, gate SR, in gate D. So this gate SR and SR latch is different. SR latch, gate SR latch, gate D latch. So both is different. Then here you can see S for set, R for reset, D for data. And the keyword that important for you to remember is a bi-stable state is one with 2 stable output stage. So what is the meaning by this? You're going to have low and high. How are you going to define this? This is the picture of the SR latch. This is the picture of SR latch. You're going to have active high and active low. Active high and active low. Active high, normally there is no bar. You can see here. But for your active low, you're going to have a bar. Okay, the output of each gate is connected to an input. You can see here, let's say you have R, no, and then you have the output, but these input are connected to your R. But another input, normally you're going to have minimum 2 input, right? This input is from the output. You can see here, from the output. So that's why it's correlate between each other. You need to check the input of S, you need to check the input of R, then you can have both connection. So the output will be named as Q and Q bar. Sorry, I need to accept someone want to join. Okay. Okay, now you have another one is active low. Active low, if you still remember your last module, NAND can be also similar to your negative or. So that's why you can also change this NAND to your negative or like this. So you have 2 types of SR latch, active high and also active low SR latch. Which when you connect to the output, to the input side, it's called as a regenerative feedback because you have the output, but you can see here is connected to the input. Let's say I give you example. You have the input of S and R 0, 0. We assume it to be 0, 0 only, okay? Here is 0. Here is 0. When you have 0, you going to have something output here before you can proceed to get the output of Q bar and also Q. So you need to know the first initial output. You can see here. Let's say our output for the first time under Q bar is 1. So it will effect here as 1. Then you will have 0, 1 for the no, you're going to have 0. So 0 will be here. 0 and 0, you're going to have 1 for the Q bar. So it will be continue later on depending on the input. Let's take a look on the symbol. This one is a block diagram logic symbols. This is in terms of the logic gates you are using. SR latch logic symbol, you're going to have SR and Q bar. Q bar, of course, you're going to have the bubble pins, which is the bar. And this is for your active high. While for the active low, you're going to have a bubble to represent as S bar and R bar. This is the only two logic symbol for your SR latch that you need to remember. It is not too hard for you to remember this. And in terms of the circuit, just now we already look also here, and it shows here also circuit for your active high input SR latch. Use no get, your input is S and R, and the output will be Q and Q bar. Similar to your active low, you can have NAND here. Use get NAND, but you can also use your negative or gate. And your input is S bar and R bar. Your output will be Q and Q bar. This is in terms of truth table. You have, this is the things that I mentioned. Normally you're going to be given with the initial previous output. Siapa lagi nak join ni? Coming late to the class. Okay, you can see here you have S, R, and Q. Let me draw just now. We have R and S. This is our Q and Q bar. Okay, now our S is 0, our R is 0, our Q is mentioned, our Q for the previous, which is the initial output, previous output here, inside the memory. So it is 0. So now you have 0 here, 0 with 0 for the get XO, you're going to get, oh no, this one is no. No, you're going to have 0 and then 1. Here you're going to get 1, here will be your 1. 1 and 0, you will get the output of 0 again for no. Please make sure you remember know how the input and output. So that's why you can see here, your output will be 0 for the Q. Here is your Q for now. Previous one, this. And now you're going to have also similar, which is 0. And after that, you can see why there is not change. This one is not changed. This one is reset. This okay. You can see here means that there is no changes from your previous to the existing new output. No change. Okay, next we're going to see 0, 0, similar input, but your previous, biar I padam dulu. Okay, now it's still 0, 0, but your previous output for your Q is 1. This is inside your memory. Now you can see 1 is here. 1, 0, you will get 0 at his part. This will be 0, 0, and 0. You will get 1. So that's why now your output is 1. And there is no change. Okay, now we look into the third scenario. Now we have the input of 0 and 1. 0 for our S, 1 for our R, and the previous output is our 0. So this will be 0. Okay, this will be your 0. Now you can see here 0 will be 0 here, 0 and 0 will be 1. 1 will become here, 1 and 1 you will get 0. So you're going to put the output will be 0 here. And it shows here, supposedly it's not changed, but why is set as reset? The reset is this one, 0 to 1. I think this should be no change. Okay, now, and then this one also no change. This will be reset. Yes, this will be reset. Yes, correct. Later on, I will double check this one. Okay, let's see the next one, but the output is correct, okay? The output is correct, which is you remain. No change from your previous 0 and 0. Let's take a look another scenario when you have the similar input, only the different at your previous output. Previous output Q is 1. Why you didn't put here? Because this is Q bar. Our given value is our Q. So that's why Q is here. Our S is 0. Our R is 1. 0 and 1. Now you can see what will happen. When you have 1 here, it will be moved here. 1 and 0, you will get 0. 0 will be given here. 1 and 0, you will get 0 for the new output. That's why you can see here now your new output is 0. Previous is 1, now is 0. You can see, let's say previous is 1 and now is 0. From 1 to 0, we call it as reset. Reset. From 1 to 0, we're going to reset. From 0 to 1, we call it as set. Daripada bawah ke atas, from bottom to up, is going to be set. From up to bottom, we call as a reset. So that's why here we are using a reset. Similar to reset, not using. Sorry. Siapa lagi yang masuk lambat ni? Okay, next you can see we have alamak hilang dah. Aduh, hai. Sekejap ya, lukis. Okay, now we have the next scenario, which is S will be 1, our R will be 0, and the previous Q is 0. So 0 will be 0 here. This one, the output will be 1 and 0 will be 0. 0, we put here 0 and 0, we will get 1. So you can see from previous is 0 to the 1, you're going to have movement from 0 to 1 is going to be set. So next you have another scenario, similar input but the difference is your previous output. Previous output now is 1. So you have 1 here, 1 will be here, and 1 you will get 0. 0 will be go for here and it's going to be output as 1 for your Q. Again, similar. So you can see there is no change at all from your previous output. And you need to remember there is invalid when you have S as 1, R as 1, whether the previous input is 0 or previous output is 1, this cannot be happen. So you cannot have S and R together as a 1. So this is invalid condition. Please remember if you have your past year question, there is a question for you. You were given with the several input. Which one is correct and which will give you invalid for your SR latch? So you need to remember there will be invalid condition if you have 1 and 1. Let's retry what happened, why it's invalid. I nak tengok kejap. 1, 1. Let's say here is 0. 0 will be here as 1, 0, 0. This will be 0. Similar. We pusing macam tu kot. That's why later on you're going to invalid. But you need to set in your mind, this is invalid, okay? So you're going to have only these things. When you have, okay, this is the summarized table. When you have 0, 0, whether the output is 0 or 1, it's going to be no change. Your output is similar, okay? Your output will be similar. While for your 0 and 1 condition here, you're going to reset your latch, this one. I don't know why it's mentioned as reset, but maybe both, you can see 0, whether the output is 0 or whether the output is 1, both will get 0. See? Both will set as a 0. So that's why it called as a reset. It is not compared to the previous, which is, this one is no change. Both is no change. Whatever output before this is no change, but whatever input output for previous one is will be getting 0. That's why it's going to be 0. Of course, this part is will be vice versa because it's bar, right? And for 1, 0, you can see 1, 0 here. Whatever previous output is going to be set as 1. It's called as a set. So the another one is invalid condition. Okay, now let me give you example, very simple one. Okay, let's say this is my S and this is my R. Okay, we have 0, we have 1, we have 0, 0, 0. We have 0, 0, 1, 0, 0. Okay, so what? This is our R. So what is our Q? So we need to check this table without looking at our previous output. We will know that with 0 and 0, there is no change at all for our previous output. So this one is need to look into previous output. But for 1, 0 here, you can see for 1, 0, latch will be set as, okay, let's say our Q is starting from 0. Our latch 1, 0, 1, 0 now, we're going to have a set. Set, it will trigger to be 1. Now the next condition is 0, 1. It's going to reset. So it's going to be reset. 0, 0 is we look into previous output. Our previous output is 0, then there is no change. So let's say the condition I just changed it to be like this. Our Q is remain start from 0, and here I change it to be R and S. Now our R is 1 and our S is 0. It will reset, so it remains 0. Reset will be a 0. And then we have 0 and 1. 0 as our... I tersilap Sekejap. 1 is R. Correct. Okay. Now is R is 0, S is 1. At this part, okay, it's going to be set. So it will be 1. And now my input is 0, 0. It will look no change. So it will follow the previous output, which is 1. So this is what happening to your output from your SR latch if you were given with the timing diagram. So here is the explanation, basically quite similar. Only you have the vice versa things. That one is active high. Just now you look into is active high. This is active high because S and R, not S bar and R bar, okay? This is S and R latches, which is active high. But if you have the active low, it will change vice versa. Let's say 0, 0. It will be invalid now. Just now for the active high, the invalid at 1, 1. But for the active low, the invalid part is at 0, 0. Okay, so please make sure you remember this. And when you have 0, 1, just now 0, 1 is reset. But now for your active low, it's going to be set. Set is what? The output will be 1. Reset is what? The output will be remain 0. Whatever output previously is going to be maintained as a 0. And for 1, 0 here, just now for your active high, it's going to be set, which is maintained as a 1. But now it's changed to be a reset. And lastly, 1, 1 just now is invalid. Now it's going to be no change, which is similar to your 0, 0 for your active high. So it is just a vice versa. Then this is the explanation for all this table. And this is the view of the logic combination to create your sequential logic. And please remember again, this one, although it is NaND, you can change this later on to be your negative, negative or. Okay, until this part, okay, before we go to another latch, let we look into this example, timing diagram. Because now I already give you one, right? Let me check another example given in this slide. You have the hint, first hint, active high, and the RS slash. If you still remember active high, you're going to have 0, 0, no change, 0, 1, reset, 1, 0, set, and 1, 1, invalid. Let we put the value first in between so it's easy for us later on. Okay, 1, 0, 0, 0. Okay, this one we didn't get first, right? So we will start at 0 first. This is our previous output. Now we look into our 1, 0. S is 1, R is 0, is going to set. So you're going to have set here. And the next is 0, 0. 0, 0 is what? No change. So it's going to follow the previous input to be no change. And the next condition will be 0 and 1. 0 and 1 is going to be reset. So you're going to reset. And you have a next is 0, 0, which is no change. It's going to follow the previous output. Then it is no change. And 0, 1 here, again, it is reset. So it will be 0. 0, 0, no change. We follow the previous output. It's going to be 0. 1, 0 is going to be set. That's why it's going to be up here. And 0, 0, no change. Is follow the previous output. You get the 1. So this is your output. So your question, the question will ask you to draw what is the output for the Q if you were given with this timing diagram. For latch, you're going to have only 2. Later on, when you have flip-flop, you have another clock part. So please make sure you understand from these 2 input, the beginning part, the easiest part, how are you going to get the output of this timing diagram. Because later on it's going to be much more advanced. You're going to have EN, you're going to have clock, you're going to have what forgot whatever. there is a lot of other input that you need to consider. That's why from this very basic 2 input only, you need to understand how to generate your timing diagram from the truth table that given here. This is the summary table. From this truth table, you summarize it. 0, which is reset. This one is no change. This one is set. And this is invalid. And you draw the timing diagram. So this one is explanation from previous example. And there is another exercise. Let we do together without looking at the solution first. Here you have, it didn't mention, or it's mentioned, active low. Wave in A are applied to the input latch as active low and determine the output of your Q for the B. Assume the Q is initial value of Q is low. That's why I mentioned it's going to give you the initial one. You were given with the initial, you were given whether it is active low or active high. Sometimes it's not given like this, but from here you know already, oh, this is SR. Okay, if as active low, if you still remember, it's going to be 0, 0, invalid, 0, 1, this is R, and S bar and R bar is going to be set. 1, 0 will be reset, and 1, 1 will be no change. Okay, let's we see over here. 1, 0, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1. Here 1, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1. Okay, now from here, you need to remember how it look like. This is your active low, and in terms of your time logic symbols like this. So you have S, R, X bar, and R bar, and you're going to have the Q and Q bar. Let's see what we're going to generate for our output. 0, 0. Okay, this one because it is initial. Okay, we start here. Kenapa kita kena start daripada satu-satu ke? Wait. Initial is low. If 1, 1, it is no change. Of course, it's going to be 0 also. Wait, I draw it carefully. Sebab nanti I tak nampak. Every single changes, it is important for you to take note. Okay, now I nak tukar color. Okay, starting is our output is low. The dimension here, low, and 1, 1, there is no change. It's going to be remain like this. Second, I have 0 and 1. 0 and 1 is going to be set. Okay, until here, 0 and 1. I have another is 1, 1. 1, 1 is no change. I'm going to remain like this. Here, I got 1, 0. 1, 0 is reset. So I will draw like this until this part. I can see here it is 1 and 1, which is no change. That's why I continue. For this part, I have 0 and 1. 0 and 1, it is set. So I set again. 1, 1, it is no change. 1, 0, 1, 0 is reset. 1, 1, no change. And this one is 1, 0 as a reset. Reset remains 0. And another one is 1, 1, which is no change. It's remain to be 0. Okay. Now here I have 0, 1, which is set. 1, 1 remain, no change. 0, 1 is set. 1, 1 as no change. So this is my output. By drawing this, you get, let's say, like 3 marks, 4 marks. It depends on the question. That's why you need to know the truth table of the condition for SR, active high, S bar, R bar, active low, latches. Okay. So any question? So you can see my drawing is similar to this, only it is quite ugly. And you can see here, that is the thing. The hint for me, although you can see in the equation, is just putting at this side. Because it's already know the answer at this, there is no changes. But for you, every single changes, whether it is at this input or this input, you need to draw like this so you can know the differentiation between these two states. So like this also you need to draw exactly. There is a changes here also. You can see this is 1 1, although it's small part. If maybe here is 0, you can see there is a different also. It will be different at the side. But in this question, I think the person that did this, because they already know 1 1, there is no changes, that's why it didn't put all the bar dotted like that. So you need to put, because you don't know at the beginning. So draw all the dotted line and then put the value inside, which is like this 0 1 0 0 1 0. You put all the value so you can easily see and differentiate it. Wow, 1 and the rest. Then you can see, okay, at this stage is what, at this stage is what, at this stage is what, the input and etc. That's why you can draw the output. You can see there here, this is the thing that I showed you just now. In the example, it didn't show you on the dotted line. Here is much more clear. You can see every single changes you need to put, because you want to see basically what is happening between at these two stages. You can see this is no change, this is set, no change, this set, and etc. Okay, this one is okay. Okay, before we go to the get RS latch, which is different, okay? Different, ya, dia tak sama, it's not similar to your SR latch. Dia, as I mentioned, it got a new input called as EN. That's why your input just now, you got only 2 input, but later on you have another input of EN. This will be also affect your output. So that's why you need to carefully understand these stages and how you're going to get your output before you can move to the next. Any question?
No, Doctor.
Okay, so I'm going to continue. Thank you. Let me continue with our next, which is our get latch. The only difference between your get SR latch and also latch SR latch and also your get SR latch is the big differentiation when you have EN, enable input. So it's your SR latch will be controlled using your EN input, and it will go when the input is high for your N input, then baru dia turn on. It's going to be turned on. If let's say the latch will no change until EN is high. If your EN is 0, nothing will be happen. Although you contoh lah, I put here another example. If you have EN, let's say you have 0 and then on, 0 and then on. So you only assume changes at this end point. The rest will be remain similar. It depends on your previous output, of course, right? It is not going to be 0. It's going to follow your previous output, no change. But at this side, okay, it's going to look into S and R. At this side, it's going to refer to S and R, what is happened. But the rest for your output of 0, 0, 0 is no happen at all. So you can see no change. And there is another one more thing, which is invalid state occur with S and R is simultaneous high, similar. If you still remember, SR for the active, high, it's going to be invalid. En1 latch is on, En0 latch is off. Okay, so that is the make you easier for you to get the output, because you just look into the En first. After you look at En, then you're going to consider your input R and S. Okay, we proceed with next. Before that, can we take a 5-minute break? Here is so cool. I'm going to go to ladies first. Okay, take a break 5 minutes. Wait. Hello, hi everyone. Let's continue. I worried because raining still yesterday, so not yet stop. Let me continue with our get SR latch. Okay, what is the difference? You can see here, this is the circuit combination from your logic, and also the symbol. So this is the symbol, slightly different just because you have another EN, another input. So altogether you have 3 input and 2 output for your get SR latch. And you can see the difference. As I mentioned, get SR latch is not SR latch. It have another input called SEN input, which is enable input. And the circuit also slightly different. When you have here NAND get and combination with your negative OR get, and this is another NAND get, and this is negative OR get. So it will be your get SR latch. If you can see, it's basically similar to your negative. You can see here, this is your active low SR latch. Active low SR latch. So this is your input of S bar R bar. With the additions of this extra circuit, you combine this with your SR latch, SR, S bar, R bar latch, you get the get SR latch. So the example here, kenapa dia terkeluar ni? So example here, you can see when you have the circuit here, you combine and you will get the active low SR latch, and you combine with this combination of logic circuit, you get altogether get SR latch. And you have Y, which is at this side equal to S bar EN dot, and another one is your Z here at this part is R dot EN bar. And this you can see as the input of your active low SR latch. If 0, Y1, Z1. If EN is 1, Y will be your S bar and Z will be your R bar. This will be changed and active low SR to active high SR flip-flop for your EN equal to 1. But you can go through and read this, but let's see what is the example of the truth table that can be conducted. Here we have S and R 0, 0, 0, 1, 1, 0, 1, 1. And whatever condition when you have EN as 0, I already mentioned, there is no change at all for your output because it's look like as it is a turn off. It's going to be turned on only when your input of EN as 1. So your truth table here 0, 0, 0, 1, 1, 0, 1, 1. What happened is if you have 0, 0, it's similar to your SR latch. No change. If you have 0, 1, it will be reset. If you have 1, 0, it's going to be set. 1, 1 is invalid. So you can see here, this is totally, this is totally similar to your previous truth table and condition for your SR latch with the enables of your EN gate. So let's say you have given with this question, you have get SR latch, find the output, and assume, as I mentioned, your initial output will be given Q as a 0. And first thing first, what you need to do, you need to draw the dotted line. As I mentioned, whatever changes, you need to draw the line. Don't follow this question because it's already know about the answer. That's why it draw at the specific line only. But for you, please draw at each changes at all the input. Okay, give me time to draw first this dotted line. Okay, now I'm going to remember back my table SR00011011 only for EN1. For EN0, there is no change at all. No change. And here is no change. Here will be reset. Here will be... kenapa I punya satu ke atas? 1011. Set and also invalid. Okay, this is my table. I hope that you also remember. Now we start with our value. We fill in the value 0, 1, 1, 1, 1. 0. 0, 0, 0, 1, 1, 0, 1. Here 0, 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0. 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1. Okay, now for my state, if first thing I am going to look into my EN. EN is 0. What will happen? No change. So I don't want to look into my S and R. I already know there is no change at all. So I'm going to draw continues from my previous output, which is 0. Next, still 0. So I'm not going to look into my SNR because still 0. So it remains similar, no change. Now I have 1. For 1, then I need to refer to my SNR. SNR is 1, 0 now. I'm going to go for set. Then I look here 0, 0, 0, 0, which is supposedly no change at all without referring to my input SNR. No change. Here is no change until I meet another 1 here. My input I need to consider, which is 0 and 1. 0 and 1, it will be reset. Now next is 0, 0, no change, no change, and I meet to my ENS1. I need to refer to my input 1, 0. It will be set. So I go for a set. I have another input of 1. I need to refer to my input. It will be 0 and 1. It will be reset. I meet another input of 1. I need to refer to my input. S and R will be set. So this is my output of Q for my get SR latch. Any question from this? Hudo lah. Hudo. It's ugly. You can see my answer is similar to this beautiful timing diagram. So you need to remember this truth table. You need to remember about active low and active high. And you can draw your output. Next,
Doctor?
Yes?
So these truth tables are like guidelines for us, right?
Is what again?
These truth tables are like guidelines that we follow when we do these solutions.
Yes, you need to remember this one. It's not going to be given. So you need
all right.
to remember this condition. Okay. So
All right,
next,
yes.
okay. So next you were given with another example. It's mentioned about get SR latch. Get SR latch, you need to remember back this similar table. Find the waveform of Q, and again, as mentioned, the initial value of Q will be given. So first thing, now it's lucky for me because it's already give the dotted line here. I only need to fill in the value 1 0 0 0 0 1 1 1 1 0 0 1 1 1 1 0 0 0 0. Next is 0 1 1 1 1 0 0 0 0. It's okay for me to put all the 0 or because you know already this is 0, right? But it's better for you to put add all the single dotted so it's easy for you to look and refer. And lastly, for my EN, enables input. Okay, let's see what is my output. Okay, I draw the table so that you can easily refer to this page. For EN equal to 0, it is no change. S and R, whatever here. And for the 1, 1, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. No change, reset, set, and invalid. Okay, so this is a truth table which is we already know the conditions of SR. We have initial value is 0 and our first EN is 0. It's going to be no change and also remain. Next, we look into our next input of EN. First thing, we're going to refer this, right? We have 0, which is no change. Next, we have 1. After we get 1 here, we need to refer to our input. S and R is 0 and 1. It will be here, which is reset. So reset, you're going to remain as a reset. Reset is what? 0. Set is what? 1. Okay. Now next is 0, 0. It will be remain, no change, no change. We meet again at this part is 1. So we refer to our input. We have 1, 0. It will be set. We have like this. Another one, EN, we need to refer to our input. We have set also. And then remain as a 0, 0, 0, 0, which is no change for this side. And 1 here is 1, 0 again. 1, 0 will be set. And then remain as a no change. And this part similar, which is set. After that, 0 again, which is remain. And lastly, we have 1 here. We refer to our input. 0, 1, it will be reset. Similar to this one, reset. Similar to this one, reset. So this is our output. So this is the answer. So you can see why and how I get the similar things. You need to check one by one. When you have one, you refer to the input. When you have one, you refer to the input. When you have one, you refer to the input. The rest for 0, 0, it will remain follow your previous output. Okay, any question? Senang kan? Markah free. Will be free bonus mark for you because it's very easy. Okay, this one is we have exercise. Basically similar things. Fill in the table. Initial value you were given with 0. Okay. So this one is not in terms of timing diagram. You have Q here. If you have, let's see, we directly go to this part, okay, for your SR latch. For 0, 0, 0, 0, there is no change at all. Before this, our Q is 0. So if it is 0, 0, it's going to be 0, 0, 0, 0. And for 0, 1, no change. And then for your 0, 1, it will be reset. And then 1 and invalid. So that is on your Q. And how about your Y and Z? This one, of course, you can directly fill in the value. 0, 0, you're going to get off 0 here. And then S is 0. R is 0. Here is 0. 0 and 0 for your NAND get, you're going to get 1. 1, right? So here will be 1. For your Y, also 1. So you do the similar thing. What is happening? You have like 0 for S, R for 1, going to get 0. 0 and 1, you get, okay, here, and then you change the value. And lastly, you're going to get this answer. Supposedly, this one, you're going to have invalid output because it is a 0, 0. But in terms of filling the answers, maybe you can follow basically what is happening for your input using your circuit, combination circuit. This one is invalid. You can see here. And this is set, this is reset, this is no change. And the rest is also no change. And this value, you just using the NAND get, input, output, input, output. So you can get the value easily. Any question? So if
No, doctor.
okay, thank you. So if let's say there is no question, we can move to our next lectures. This is your last latch. If you still remember, you only have 3 latches. SR latch, get SR, and another one is get D. So here is our get D. Much more easy, I guess, because you only have one input. Only have one input, which is your data there. And of course, you're going to have the trigger of your EN if you have git. So it's going to have 2 input, EN and also D. And this is the combination get for you to check how you're going to get the logic diagram for your get latch. And this is the logic symbol. So let's take a look. What is the characteristic? From here, it is a similar thing. This will be your SR latch, but the only difference, if you can see just now, without this NOT, you're going to have another input of R. This one is S. It's similar to your get SR latch, but instead of this R, you just use this similar input of D. You put the NOT there, and it will be your get D latch. This is direct input for your D. This is your NOT. This is the only difference between your D get D latch and also your get SR latch. Okay. Now you can see this is your get SR latch. When you add another NOT, you're going to have the get D latch. This is your SR latch. So you can see the flow from SR latch to your get SR latch to your get D latch. And it is slightly easier for you to remember because the truth table and the condition hanya sikit je. It's only few for you to remember because you have one input, the D only, right? Depend on your EN. If you still remember, if it is 0, nothing happen. So your D, either it is 0 or 1 only. So that's why you got only these two conditions. If your D is 0, your output will be 0, which is similar, which is reset. And for your DS1, it's going to be set and also 1. This is similar thing for your get SR latch. EN is 1, your latch is on. If EN is 0, latch is off. Okay, you can read and go through this. Let me directly go to the example. We go directly to the example. We need to remember we have EN, we have D. If 0, nothing happen, no changes. If 1, we have either 0 or 1 for our D. We have here as a 0 or set for the output. And it will be 1 or a reset, set. Okay, now we have Q. Initial value will be given. It will be 0. Before that, please make sure you draw every single dotted line. Kenapa lah dia tak draw kau untuk saya dulu? Ya Allah, bodohnya. Okay, the rest is similar. Okay, now I put the value. We have 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0. Ayan. Beras. Okay, next. Mana saya punya? Okay, next you can see 0, 0, 1, 0, 0, 1, 0, 0. Okay, my output. I tukar warna lagi. My output, first it is 0, so no change. This one is no change. It will remain the same. Until I meet my 1 here, I need to refer to my D or my input. D is 1, I'm going to get 1. This here, I have 0 is remain no change. This here is 0, remain no change. And I meet 1 here, I need to refer to my input. My input is 0. Here is 0, no change. Here is 0, no change. Until I meet another one is 1 here. I refer to my output and input as 1. Here is no change. Here is no change. Here is no change. No change until I meet 1 here. I need to refer my input. It is 0. And I have another one here. Will be 1. Here will be 0. Here will be 1. Here will be 0. So this is my output. So sama kan? It is similar to my drawing. This is your table. You can draw and get the similar answer following the scenario given. Okay, any question? For this part, kenapa I tak just jump? So if there is no question, I want to move also. Before that, maybe we have another 30 minutes. We go through on your. After this, you're going to go for flip-flop. But before you can go deeper, we're going to continue tomorrow. But we look into your project. Okay, the question saya rasa doktor ni salah tulis. It should be 1, 2. Okay, the question is prepared by Dr. Fuad and Dr. Ismail, similar to all section. We have all together 10 section for your digital logic this semester. So all is similar. You're going to have a real, mana pen saya? A real system electronic controller simulation. Kenapa saya tak boleh draw? Okay, a real system electronic controller simulation. Simulation using your DIT software. And remember again, this is project group. And you need to follow your lab group that I assigned last time. Okay, so what is inside your project? This project is done in a group of 3 or 4, I guess. Sometimes you have 5, I forgot already. But it's okay as long as you follow the group that I assigned last time for your lab. And there is several parts. Part A, Part B, and your integration of both parts. So what is inside? For part A, you have the combination logic. If you still remember combination logic, you have a comparator, you have the adder, you have marks, you have demarks. So all of that you can use. And you can freely use which of the combination logic, but depending on the scenario will be given. Okay, this is briefing first on your part A. And advanced accessory, you can add another. It depend on your creativity. Let's say you nak add on another get not ke, another get and ke, nan ke. It's all on your creativity. Or maybe you want to use your dual symbol So you freely to use. Second, you have part B. For your part B, you're going to have a sequential logic. This is the one that we just learned. You're going to have the counter design, the clock enable. Clock, this one you will learn on your flip-flop. Okay, so I'm going to record a video, maybe especially for the project, and about the clock and the flip-flop later on. Advanced accessory also you can use, depend on your creativity. And lastly, we call it as a part C or part integration part. You combine your combination logic from your part A and also your sequential logic from your part B. You're going to integrate it together. And you can also have extra and advanced accessory if needed. Okay, example here, if you look at your right side. You have here a system controller in your lifetime. So you ada beberapa like your evaluator, what else? Photostat machine, car park, vending machine, ATM. So mostly all the students always pick this one. Maybe it's easier, but the rest is also we can pick. Depend on your discussion with your group. Let's say you pick example of scenario what you want to do, and you need to design, choose a real system from the list given and study how the system works. If let's say for your vending machine, how it goes, for the lift, okay, for the lift, let's say if someone click 1, how your lift will be go to number 1, level 1. If someone click at 2, how your lift will be go to the 2, and so on. So you need to figure out how the existing scenario relate to your combination logic, to your sequential logic, and you're going to integrate it. You're going to determine the input. What is the input? Maybe someone press the button only, right? Button at your lift, button 1. So this button 1 is what input? Is it only 1 or maybe it is 0, 0? If 2, it is 0, 1. If 3, 1, 0 is 4, maybe it is 1, 1. So you are going to decide yourself. And about the process, let's say you have from here, you want to go to this one. So what is happened? From this state, you're going to go to this state. What has happened? So you need also to remember that, right? Which is currently you are at level 1. So your output shows that it is level 1. And when you press 2, of course, it's directly to go to. If let's say you want to go from 0 to 4, so you need to remember currently you are at level 1. If you are at level 3, you can remember that it is level 3, you can go for 4. So all the connection all together, you need to have the flow. Later, when you go through your module 7, you can see it more clearly, especially on the situation. Categories. Which part of the system fell under combination logic and which one is sequential logic? Okay, yang tadi, let's say you have 0, 0, 0, 1. If you direct go to here, is this a combination logic? Or maybe you need to have another output there. This is the sequential logic. So this type of drawing, later you will meet. Later you're going to meet it also in where is it? Not yet here. Oh, the drawing is not here, I guess at module 8. But you're going to meet it. We're going to discuss it together. But from now, starting point, I want you to discuss with your team member, and you need to find which one, the project that you want to focus. Okay, example, operation scenario, which is behavior. You may choose any system that you want to design the controller and study how the system works. Example, the controller for the lift building up and down. You can read here, a hotel visitor want to use a building lift to go to the up from one level to another. The requirements are put in the desired level to go. Tag the visitor room card, choose the lift, because normally our visitor will have the numbers, right? Numbers of rooms. Push up button, then the lift will go up by counting up one level to another. Level 1, level 2, level 3 is going to count until it reaches to the desired level. The door will be open at the same time. Alert will be given to the visitor. Similarly, to reverse process happen, which is you going to turn down when the visitor go down. The counting sequence will decrease until it reaches to the desired flow. So you can see at this scenario, you have two cases that you need to check, which is when lift goes up, and another one is when lift goes down. So you need to list out what is the requirement, the key in level up, what is the user key in, let's say 7, and then tag in the car hotel. If let's say your room number is 6 until level 6, can it go for 7 or not? So that is all the requirement for the card tag, right? And then whether the door is closed or whether the door is open when it reaches to the destination. Lift go up to the destination, stop at the destination, sound notification, and door open when it reach. So scenario, all this scenario you need to discuss. There is several, right? You have lift, you have photostat machine, you have car park, vending machine. So maybe you can also try Google what is the scenario, what you're going to determine. And this one is example if you have at level building. So you can see here. So as I mentioned, you are the one who assign berapa tingkat, how many floors that you have. And maybe for level 1, what you're going to decide. It's going to be 0, 0, or maybe it is going to be 1, 1. So you need to explain all in your report. And this is example how you have a block diagram for complete circuit. You have here a combination circuit, you have a sequential circuit, and you can also add another advantageous features, which is your display, clock. So you can see the advantages, the extra features you add here is the display. And this one is the things that you can use for your part A and things that you can use for part B. For part A, normally you already cover all, but part B, you still need to learn until, I guess, module 8. I try to speed up. Maybe by tomorrow, we're going to finish our module 7. At module 8, we will try with the video, and next week, we're going to learn together. And you need to use all the features inside. Then you can see the overview. So this one is another example how you're going to do the part A and also part B. This slide already given in your e-learning, you can check. And what you need to submit. You need to submit the report. The format of your report, you need to use the Time New Roman 12 font, 1.5 spacing, turn on your MS Word spell and grammar checker, of course. Then what you should have: title page, acknowledgement, table of content, report content, whatever you are doing in your project, reference, and appendix. Appendix is like mostly you're going to put all the picture, and maybe if let's say you have extra references that you need to put in your appendices, also can. This is the content of your project report. From background, problem, let's say the problem for you to justify on the lift. User want to go up and go down. Suggestion solution must include the block diagram and explain. The requirement, system implementation, you need to use the DIT simulator to draw. Don't use like Microsoft Word, or maybe you use pen. You need to synchronize using the DIT simulator drawing. Maybe you save it or you screenshot and put it and paste into your project report. And lastly, the conclusion. So this one, we try to finish first until module 8, then you can continue. But before you go for in-depth, you need to start from now. You need to discuss with your group which one. Maybe you can also find all the references. You can see here, you need to list all the references also. So you try to search in Google, whatever references have, you can list later on and see there is several scenario that you can use. So try to Google which you want to use. Lift, photostat machine, car park, vending machine, ATM machine. After you already Google, you already finalize, then later on you can go step by step. That's why I give you directly this week for you to start discuss with your team member. So any question?
When is the deadline for this, doctor?
Normally at your study week, I guess.
Revision week?
February. What? Study week?
Oh, so it's revision week. It's actually week 15,
yes.
right?
Yes, but as mentioned, the academic calendar not yet confirmed. We still wait for Senate whether we want to extend 1 week or not. So the final due date I'm going to share later on, okay?
All right.
But you need to start from now.
Yeah, sure.
Okay. So any other question? So if there is no question, you can download where is it? You can go to your e-learning there is a QR code for you for those who just joined our session. And here is your group slide. You can see here everything. So you can start discussing with your friend and team member. If there is no more question, we can dismiss and meet again tomorrow morning. Stay safe and bye-bye.
Thank you, Doctor.
Thank you, Doctor.